So the bridge is an element, and it's an element of, or let's say, a piece of a puzzle. So in order to get to that piece of the puzzle, you have to actually build all the other pieces around it. And I like to call it like a puzzle because in the end of the day, we have somehow, from an engineering perspective, to find out how all these are coming together. So we had to do a slight modification on site, for example, to ensure that this bridge will fit and will actually have enough tolerance on a night to actually land it. So you need to land it, secure it, remove the crane, and then you have enough time to attach the bearings on it and actually lock them in place as such. So all this is a process that you have to plan through months and months and months to ensure that your abutments have been built in time, to ensure that the bridge will come in time, it will be assembled on site, and months in advance of actually lifting it in, so you have enough time to actually put the deck in. So all these things are elements that you need to actually plan 6 months out. We focus on the engineering element, and I want to actually draw your attention on the logistical nightmare over here and the amount of interfaces that we have. So I want to draw attention on the fact that on the north of the bridge, you have the interface of narrow rail. On the east of the bridge, you have the interface of Jubilee line, which is part of the wider Transport for London network. And then you have DLR, a private limited company that runs a franchise that runs services. So you have 3 different entities there with different interests. Location, as I mentioned from the start, is very intriguing, is very complicated. So if someone stands back and look at the location, again, I'll talk about the interface. So you have a viaduct on one side, which is a bridge, okay, where a narrow rail runs their trains. Then you have 4 lines from Jubilee line and DLR, and then you have the station building in the middle, which has a certain elevation. So we need to actually map the whole area. So when we actually lift in the load, we need to get enough height to get it over it. And also the biggest challenge for us is how you control that load as it's actually traveling over all these assets, because it's up in the air and you don't have control of it, supposedly. However, we came up with a solution where we actually have tag lines, some of them already rolled up there, some are quite long and actually secured back to a telehandler that acts as an anchor point, so the load is always controllable and can spin uncontrollably, if that makes sense. And we came up with some sequence to be able to be in control of the load throughout the whole path of the installation.